In this video, we are going to learn how to calculate a chi-square test for independence. This is a test that allows us to determine if there's a difference between some categorical variables when the data are in count or frequency format. This chi-square builds off of the more familiar chi-square where you're comparing observed and expected values. The difference here is that we don't have expected values. We actually are going to need to use the data that we've collected to determine our expected values. So let's walk through an example. Here we're going to be working with the null hypothesis that says there's no difference in the number of eggs hatched from the mung beans or the adzuki beans. There are going to be 5 steps to mastering the calculation, and they begin with entering data in what we call a contingency table, then determining the degrees of freedom, finding the chi-square critical value for your degree of freedom, and then calculating the test statistic and comparing the chi-squared and the calculated values. So we'll begin by organizing our data into a contingency table, which you can see over here to the right. What we have are the bean types, and then we have data on the number of eggs that hatched and the number of eggs that did not hatch for each bean type. And then we go ahead and we sum across the rows to give a row total, and we sum down the columns to give ourselves a column total, and then we give ourselves an overall total here in the bottom right, which is colored in orange. To determine the degrees of freedom, then, we will take the number of rows minus 1 times the number of columns minus 1. And in this case, we have 2 rows for the mung and the adzuki, and we have 2 columns, the number of eggs hatched and those not hatched. So our math is pretty easy here. We've got 1 times 1, and that becomes 1. And so our chi-squared critical value is a number that we're pretty familiar with already, and that's a value of 3.841. Okay, up next is actually going to be calculating the chi-square test statistic, which involves observed and expected values. First, we need to actually calculate the expected values for our data set based on the data that we've already collected. And so what we need to do is use this equation. We're going to take the row total and the column total for each cell and divide it by the grand total to come up with an expected value for that particular cell. So let's take a look at it. Here we'll start with the mung bean. We've got the number of eggs hatched, which we are going to take as the row total for that bean, which up here is 45, and multiply it by the column total, which we have here as 42, and then we're going to divide that by the overall total, which is 72. So you can see we've got 45 times 42 divided by 72. If we move over to the next column, we're going to still have a row total of 45, but this time we have a column total of 30, so our math will be 45 times 30. We'll continue to divide by 72. So we're going to continue to fill out our table here to determine what our expected values will be, and then when we walk out the math, you'll see that we actually get values here ranging from 11.25 up to 26.25. These become our expected values. And now we're going to use the chi-square that you're really familiar with. Observed minus expected divided by expected, that equation. And so we'll start out by placing the mung beans over here, and the number hatched and not hatched, each getting their own rows, the number hatched and not hatched for adzuki as well. We'll place in our observed values, which come from our very first contingency table. So 35 eggs hatched for the mung goes down in this portion of the table, and we'll fill out the rest. We'll take our expected values, which we calculated just beforehand, and place those in their appropriate row as well. And then we'll do the math. Observed minus expected squared. Observed minus expected squared divided by that expected value will give us a final number, and then we can sum all the way down this column to give us a chi-squared calculated value of 18.66. This is the number that we are actually going to go back and compare to our chi-squared critical value of 3.841. If the chi-squared calculated value is greater than the critical value, we make one decision, and if the chi-squared calculated value is less than the critical value, we make another decision. So that will give you the answer to your question, your null hypothesis. Is there a difference between the number of eggs hatched in these 2 bean types?